Evacuating high-rise construction sites is one of the most challenging evacuation environments conceivable. The reason for this is the complexities you find on construction sites. For a start, all of the fire safety measures that are normally in place in the completed building can't be made operative. So you don't have a sprinkler system active, you don't have a fire detection system active, you don't have the compartmentation active, so a fire can spread rapidly, smoke can spread rapidly throughout the space. So you have really none of the normal fire safety features that would normally be available in a building are in place. The next thing you have is that the building environment is constantly changing. As the building is going up, it's changing in the interior. So paths to evacuate might no longer be available. The stuff that you had, a path you had available yesterday is no longer available today. On top of that, you've got floor surfaces. The floor surfaces are not just flat concrete surfaces. You could have decking. You could have decking with rebar. You could have all types of different surfaces that make it difficult to walk over. And then you have the stairs. In a high-rise construction site, the stairs are not usually completed, and so you have a temporary stair in place, usually made of scaffolding. How quickly do workers walk on this temporary surface, temporary stairs? And then what happens if you don't even have a temporary stair, you have a ladder? How quickly can workers go up and down ladders? Then you've got the noise in the environment. It's a very noisy environment. So not all the workers can necessarily hear the alarm, and some of them are wearing ear protectors. So if they've got ear protectors on, they've got no chance of hearing the alarm. And then you've got workers who are doing tasks that can't just be left, even if they can hear the alarm. Sometimes the workers have to make what they're doing safe before they can leave it. And then you've got workers working at height, on a crane, or as part of on a cherry picker. How long is it going to take them to evacuate? So all of these aspects make evacuating construction sites very challenging. And then we have the regulatory environment. There are no regulations governing how to make a high-rise construction site safe. We have guidelines, but we have no hard and fast regulations. And the guidelines are based on a bunch of magic numbers. We don't know how long it takes workers to respond to an alarm. We don't know how quickly workers can walk over these surfaces. So how can you make guidelines or regulations? This is where we came in. In partnership with IOSH and Multiplex, we ran a 3-year project to run experiments in high-rise construction sites. In total, we ran 4 unannounced evacuation trials in high-rise construction sites, and we ran 5 separate trials measuring the speed of workers on different types of surfaces. In total, we had over 2,000 people participate in these trials. And as a result of the trials, we've created a unique evidence base. It's the only one of its type in the world, and we have data that can be used to explain and describe how workers will react and behave in evacuation on a construction site. And using this information, we can better shape and frame guidelines and regulations, and we can do computer simulation on how to evacuate high-rise buildings. We ran 4 unannounced evacuation trials in 2 different high-rise buildings at 2 different heights. So we collect a massive data, certainly the largest data set for construction site evacuation in the world. Some of the things we wanted to measure was how long it took people to react to the alarm, and if they knew how to find the way out of the building. What we found was that about 1/3 of the participants knew the exit route and knew how to get out, but about 1/4 of the participants had to look for emergency exit signage to help them find the way out. We also found that the longest time it took for people to react to the alarm was about 6 minutes. This is in the main part of the building. Up to 6 minutes to react to the alarm. That's an awful lot of time. And then what we also found is that once people disengaged from their pre-alarm activities, some would begin their evacuation straight away, but others would do other tasks like pack their tools or go and talk to other people. So people didn't react immediately to the alarm, and that's what delayed the response. And in a high-rise evacuation building, every second counts. every second can make the difference between life and death. So it's really essential that people react quickly to the alarm. The other thing we measured was how quickly people could walk over the different surfaces. And what we found was that on the temporary scaffolding stairs, workers would descend at a walking speed which was about 74% of what the normal speed would be on a stair. And when it came to ladders, the speed at which workers would descend between floors on a ladder, it was about 50% the speed, a normal speed on a stair. So these are huge reductions in travel speed on stairs, which you need to take into consideration when you're planning an evacuation of a construction site. The other thing we found was the different types of floor surfaces that people walk on. And if you're walking on decking, especially if you're walking along the ridges of a decking, the travel speed can be reduced by down to about 68% of the normal walking speed on a flat concrete surface. So again, the speed at which the workers can walk over the surface is greatly reduced if the surface is one of these temporary surfaces. And again, you have to take this into consideration when you're planning your evacuation strategies or when you're going to simulate the evacuation. So using the data, we modified our Exodus evacuation simulation tool so that it can simulate and represent what goes on a construction site. And Exodus is now the only software tool in the world that can simulate evacuation from high-rise construction sites. And here we see an example where we're exploring using the hoists to speed up the evacuation process on a high-rise construction site. And what we found was if you have a construction site of up to about 40 floors and with something like 600 workers on the construction site, you can speed up the evacuation using the hoist by about 25%. So you can reduce the evacuation time by 25%. That's a huge amount if you can use the hoist. The important thing though is what we found was it's very much dependent on the capacity of the hoists and the speed of the hoist. On construction sites you'll find a whole variety of different types of hoists. Some of them are slow and some of them have smaller capacity. To achieve the results that we're suggesting is possible, you need to have the fast hoist with the large capacity. So as part of the research work done here at the University of Greenwich, we've created the world's first evidence base describing how workers in high-rise construction sites react and behave. Using this evidence base, we hope we can make the construction site environment safer for all those involved in high-rise construction all around the world.